This is pre-calculus notes on factoring difference of two squares. All right, so anytime you've got a polynomial with two terms and both terms are perfect squares, and it's a difference, that means a subtraction, whoops, you can use this formula for the difference of two squares. This is very easy. So what you do is you're going to set up your two parentheses, and the square root of the first term is your first times first. So the square root of x squared is x. That goes in first times first. And your 25, square root of 25 is 5. That's last times last. One of them is a minus, the other one's a plus. That's it. It's that easy. All right, problem number 2. So the square root of 16t to the second is 4t. That's first times first. Square root of 9 is 3. That's last times last. 1 minus 1 plus. All right, sometimes you can factor it more than once, right? And so if you can continue factoring anything, you always have to continue factoring until it's not factorable anymore. So here's an example of that. Problem 5, the square root of 16x to the fourth is 4x squared. And your square root of 1 is 1. 1 minus 1 plus. Okay. Now, this is factorable. Okay. The other one is not because there's a plus. And in order to use the difference of two squares, it has to be a difference. So, my first is going to become 2x minus 1 times 2x plus 1. And then the second polynomial is just going to come down as 4x squared plus 1, because that's not factorable. All right, the one underneath it is exactly the same. Okay. So I've got the square root of x to the fourth is x to the second. That's a 2. The square root of 81 is 9. All right, now x squared minus 9 can be factored. Again, that's also the difference of two squares. So it's x minus 3, that's a 3, times x plus 3. X squared plus 9 cannot be factored. That comes down. All right, let's keep going. Okay, again, we're using multiple factoring steps. I know that, and you always want a GCF first. So anytime you can pull a GCF out, you want to do that first. I want to see if, you know what, I'm sorry, I'm stuttering. 256 is not divisible by 3. I was looking to see if 3 would go into both terms, but it doesn't. Is 256 a perfect square? I'm just doing this in my calculator. Yes, it is. I just did in the calculator square root of 256, which is 16. So they are the difference of two squares. So I'm going to do 9x to the second, that's the second, minus 16, and 9x to the second plus 16. And again, 9x to the second minus 16 is the difference of two squares again. So that's 3x minus 4 times 3x plus 4 times 9x squared plus 16. All right, problem 8 is a GCF first. Anytime you can find a GCF, always pull out the GCF first. So I'm going to divide 2x to the second out of both of those two terms. And 32x to the sixth divided by 32x squared is 16x to the fourth. Negative 2x to the second.
All right, so now inside the parentheses, I've got the different